Hello, I'm Abdul Raheem, a 9-pointer from IIT Bombay. In this video, we will be solving some questions from ordinary differential equation. This was the questions from a quiz that was held early on in the course on 2021. So this will be covering some initial topics only from ordinary differential equations. Okay, I had solved the initial 3 questions in an earlier video. So you can check on the channel if you haven't watched it. In this video, I will be solving only the fourth question since it's a little bit lengthy and an important question. We will solve the remaining questions in upcoming videos. So stay tuned to the channel. Now let's get started with the question. Consider a small disk in which the differential equation 1 by y plus tan y plus 1 by x minus cot x into dy by dx equal to 0 is well defined. An integrating factor for this differential equation in that disk is given by. So we have to find an integrating factor for the given differential equation. What is an integrating factor? Suppose a given differential equation is not exact or closed. In that case, we are multiplying the entire differential equation by a function mu of x comma y. Okay, it's a function of x and y. Maybe x alone, a function of x alone or y alone. But a function of x and y which get when multiplied with the differential equation will convert the equation into a exact ODE so that we can solve it easily. So we have to find such a function. We have some standard techniques to find such functions of x or y, but it's not sure that we can use that method solve it. Sometimes it would work, sometimes it won't. You know about those conditions, right? But from here you will find that from the options itself it shows that it's not just only a function of x or y, it's a function of both x and y. Okay, in that case we don't have any standard technique, but one way that we can use will be explained in this video. So we can just observe that the given equation is actually a separable ODE. So first of all, let's simply solve it by the method of separable variable technique. Okay, so the differential equation is 1 by y plus tan y into 1 by x minus cot x. Sorry, there will be a plus sign into dy by dx equal to 0. Okay, let me just solve this by the normal technique. So that would be 1 by x minus cot x into dy by dx. That would be, it's negative. So let me just rewrite the parts inside. Yeah. So cot x minus 1 by x into dy by dx equal to 1 by y plus tan y. Okay. Now again rewriting, it will be converted into dy divided by 1 by y plus tan y equal to dx divided by cot x minus 1 by x. Just simplify this, it will be y dy divided by 1 plus tan y. I'm just taking that y common into the denominator and taking that back to the entire numerator. Okay, here that will be of the form x dx divided by x cot x minus 1. We have already observed that our options were in terms of x, sine and cos, right? So let's convert this tan and cots into sines and coses. Okay, so that would be of the form y dy with an extra cos y coming from the entire denominator, and we will have here cos y plus sine y. 1 plus y tan y it's supposed to be. Okay, so we'll have cos y plus y sine y. That is equal to, similarly here we will have x sine x dx divided by x cos x minus sine x. Okay, so this is a nice separable equation. We can just solve this by integrating on both sides. But to integrate that, you have to notice something. If you consider the denominator thing as a function, f of y is equal to cos y plus y sine y. Try finding its derivative. What is its derivative with respect to y? That is, the derivative of cos will be just minus sine y plus, what is the derivative of y sine y? It would be y into cos y plus sine y into 1. Okay, now these two terms minus sine y and sine y get cancelled and we have the derivative as y cos y, which is exactly our numerator in the integral. So this is something of the form integral of f prime divided by x. We know the answer for that differential equation for that integral would be log mod f or log mod denominator, which will be cos y plus y sine y, which is equal to, how can we integrate the second part? let's try the same technique. It should work probably. So f of x is equal to x cos x minus sin x. This is the equation. What is the derivative with respect to x? F prime of x is x into derivative of cos is minus sin x plus second function cos x into derivative of x will be simply 1 and minus derivative of sin x will be simply cos x. Now these two terms get cancelled and we have the derivative as simply minus x sin x. This is the derivative. Okay. Now we have the numerator as x sin x. So let's simply take a minus outside and integrate it. So it would be minus log mod x cos x minus sin x plus a constant c. Okay, let me just rewrite that well here. That would be log mod y sin y plus cos y plus log mod x cos x minus sin x equal to c. Okay, now just adding this log, we have to log x plus log y is xy, right? So that would be log of y sin y plus cos y into x cos x minus sin x, that is equal to some constant c. Take exponential on both sides. The left side will have y sin y plus cos y into x cos x minus sin x. And in the right side, we will have e raised to c. Exponential of some constant. That is again another constant. I just denote it by k. Okay. Now, once we have found the implicit solution, we can differentiate this equation again to reach back to the differential equation. But we may find the differential equation in some little different form. That's possible. This was the technique I was slightly referring to earlier. Okay, we can just differentiate this equation and try to get back to the differential equation. So let me differentiate by x on both sides. Okay, so let me use the chain rule. First function into derivative of second function. So the derivative of x cos x will be again using the chain rule, x into minus sin x plus cos x into 1, that is simply cos x, and minus the derivative of sin x will be cos x plus second function into x cos x minus sin x into derivative of y sin y, that would be y into cos y. Remember, there will be a dy by dx also, plus second function, that is sin y, into the derivative of y will be simply dy by dx, and there is a cos y whose derivative would be minus sin y dy by dx, and this being equal to 0. This is our expression. Okay, now you can see that this cos x and minus cos x get cancelled, and the sin y dy by dx and minus sin y dy by dx get cancelled. So we have a simple nice form, y sin y plus cos y into minus x sin x, then plus x cos x minus sin x into y cos y dy by dx, that is equal to 0. Okay, now let me just multiply the entire equation by minus 1 so that the equation looks little more well with the first term being positive, right? So there will be a minus coming here, but I will take that minus inside this bracket. Okay, so that on simplification gives x sin x into y sin y plus cos y, then plus sin x minus x cos x into y cos y dy by dx equal to 0. Okay, do you remember our earlier differential equation? What was the question actually? It was 1 by y plus tan y plus 1 by x minus cot x into y prime equal to 0. Now let's try to bring the differential equation into this form. Okay, now the coefficient of dy by dx was 1 by x minus cot x, right? So we have to modify this term. How we can bring this into this form? Let's just divide this by x sin x so that x and x get cancelled and there will be a cot term, and here sin and sin get cancelled and we will have a 1 by x. Okay, So in order to nullify this effect, I also will have to multiply it by sin x. Okay, similarly, let's convert the other part also. We have to convert this into 1 by y plus tan y. So for that purpose, I will divide this by y cos y, and in order to nullify this effect, let me multiply here also. Now you can see that xy sin x cos y is present in both the terms, right? Xy sin x cos y, yeah, that's found in both the terms. So let me just take out those terms, xy sin x cos y. And what are the remaining terms? Here we will have tan y after cancellation and plus a 1 by y. Then plus, here we will have 1 by x minus cos x by sin x, that is simply cot x, into dy by dx or y prime, that is equal to 0. Okay, now you can see the same equation once we found the solution and later found the differential equation from that solution. Now the question actually looks in a slightly different form, but we can just go in the reverse direction and find the solution, right? So this xy into sin x cos y, which is a term which gets extra multiplied, and it actually gives us actual solution. Like, this extra term actually helps us easily to find the solution. So it should be converting this into the exact form, right? So this extra function that we have found is our integrating factor. So integrating factor is xy into sin x cos y. Okay, so let's check if this is in the option. Yeah, this is the second option. This is the correct answer. Okay, I hope that it's clear. And in the upcoming videos, in the next video, we will be discussing the remaining questions. So subscribe to the channel so that you can get the notification. Join our Telegram group and Instagram account. Follow the Instagram account so that you can get updated with whatever is going on in our channel. Okay, so see you in the next video. Bye.